Greetings and welcome back. This is N1IR. This is section 13, multimode radio excitement. Let's begin. Okay, there's the first 10 and we're up to section 13, multimode radio excitement. Right, a transceiver is a unit combining the functions of a transmitter and receiver. Years ago you had a separate receiver and transmitter, and they combined them together, and they actually share some of the same circuitry inside. So it's a more compact unit than many years ago when we used to use 2 units instead of the single transceiver. A multimode VHF transceiver is useful for VHF weak signal communication, and that is because you have the option of using sideband. So that is your multimode. It can do upper and lower sideband, AM, FM, and speaking about sideband, SSB, single sideband, is the voice mode which often used for long distance weak signal contacts on VHF and UHF bands. Single sideband is also used in the HF bands as well. But if you want to go really long distance on VHF, UHF, you want to use single sideband, and we're going to get into that in the next few slides on why that has an advantage. You can take a look at the signals. This is a spectrum analyzer, so you're looking at a frequency versus voltage. And you can see a carrier-only CW, continuous wave. So when you hold down the microphone, don't speak into it, don't modulate it, it looks like this at a specific frequency. Now when you're in AM, you produce the carrier plus 2 sidebands, an upper sideband or lower sideband. So there's a lot of wasted energy in creating the carrier and the sideband because it contains the same information. So your upper and lower sideband, when you're in the AM mode, is exactly identical for information. So what single sideband does is it takes out the main carrier and removes one of the one of the sidebands, either the upper or lower sideband. It suppresses it, and it becomes single sideband. And later on in your receiver, it gets regenerated with what's called a BFO, a beat frequency oscillator. And you have a second oscillator in your receiver that you add this onto the signal sideband that you're receiving, and it recreates that in your receiving radio. So the nice thing about single sideband is it concentrates all that power into one of the sidebands. Oops, went the wrong direction. The primary advantage of single sideband over FM voice transmission is single sideband has narrower bandwidth. So if you look at single sideband, it's about 3,000 Hertz, really about 2.8 kilohertz. AM requires about 6 kilohertz, and FM is anywhere from 5 to 15 kilohertz. CW is the smallest, that's only 500 Hertz, and fast scan TV is the largest, which requires 6 megahertz of bandwidth. Single sideband is a form of amplitude modulation. Upper sideband is normally used for 10 meter HF, VHF, UHF single sideband communication as a communication mode. Now, is this de facto standard? No. You can use lower sideband on those as well, but usually, normally, you'll see upper sideband. Modulation describes the combination of speech with an RF carrier signal. So amplitude modulation, here's your carrier signal, and the modulation, here's the modulating signal, gets transposed over that carrier signal, so it varies in amplitude. 3 kilohertz is the approximate bandwidth of a single sideband voice signal. So 3 kilohertz is the rule of thumb. So for example, you're on the 15 meter band, and you, as a if you're in the general class subband, you have a frequency range of 21.275 to 21.45. Now you have to keep in mind your sideband and where your tuning is. So if you tune to 21.275, you're going to be okay because you're going to be in the upper region above 21.275. However, you want to be careful with upper sideband not to get too close to the upper edge. The maximum you can have is 21.447 on your indicator on your radio, and you don't want to go beyond that because then your sideband would be out of band. And rule of thumb is I would actually go a little bit lower than that because your tuner can drift a little bit as well, especially some of the older radios. The newer ones now are pretty stable, but if you're using an old vacuum tube radio or something from like the 70s or 80s, they tend to drift a little bit. And you just want to keep that in mind. Where you're tuned, if you're using upper sideband, it's going to be plus 3 kilohertz from where you're tuned. If you're on lower sideband, it's going to be the lower 3 kilohertz from where you're tuned. So this is what's going to be on your display. So you just want to keep that in mind when you're operating. 2,400 hertz is the appropriate receive filter bandwidth to select the order to minimize noise and interference from single sideband reception. So remember we had 3 kilohertz wide. These filters will filter that even further down to 2.4 kilohertz. So that's a single sideband filter. The use of single sideband phone is permitted in at least some portions of all bands above 50 megahertz. The receiver RIT or clarifier controls could be used for voice pitch of a single sideband if it seems too high or too low. So if you don't want to change your frequency, you can change the RIT to get the other station in a little bit clearer. It's called a clarifier. And you don't have to change your frequency at all. You're just changing the pitch or the tone of the single sideband coming in. So RIT means receiver increment tuner. So this is just the receiver side that you're changing the frequency on, not the transmitter side. Some microphone connections on amateur transceivers include push-to-talk voltages powering the microphone. So this happens to be an ICOM pinout. So we have 8 volts. We have a frequency up, down, a squelch switch, PTT, ground, microphone ground, AF out, audio out, and microphone input. So this is a circular 8-pin connector. And there's a variety of connectors out there for microphones. This is really popular. There is a RJ45 connector, which is an 8-pin that looks like it plugs into your network card. And there's also, Yaesu has a 6-pin version of that. I believe it's an RJ11. The name of the circuit that generates a signal of desired frequency is called an oscillator. The type of emission that is the narrowest bandwidth is CW. Remember, that's 500 hertz for CW. 150 hertz is the approximate maximum bandwidth required to transmit a CQ signal. .500 hertz is the approximate receive filter bandwidth to select in order to minimize noise and interference for CW reception. So if you looked back in the previous slides, a lot of HF radios have optional filters that you can put in. This one has option filter 1, option filter 2. So if you work a lot in single sideband, you can have a couple sideband filters in here, or if you work primarily in CW, you can have a couple CW filters, or mix and match. One for single sideband and one for CW. And there's a lot of options you can do for the HF radios for filters. And you can make your own filters too. The advantage of having multiple receive bandwidth choices on multimode transceivers that permits noise or interference reduction by selecting bandwidth and matching the mode. So when your radio comes stock, it comes a little bit wider than 3 kilohertz for single sideband or 500 hertz for CW. So you can further narrow that down and really tune in It's really for receiving and really tuning in that station. If you work the CW band, I've heard the CW band before, there's a lot of people operating in that short segment of the band, so it gets very congested. So if you have optional filters, you can take that congestion out and just narrow in on just that one station you're trying to work. It's a really nice option to have on some of the radios. Alright, so FM. Okay, so this is the new FM frequency bandwidths. So what they're doing in FM commercially is they have a 25 kilohertz bandwidth for FM. They're shrinking that down to 12.5 kilohertz and at a 7.5 spacing from existing channels. So we're going from a wide band FM to a narrow band, and a lot of amateur radio is starting to transition over to the new narrow band. And what that does is it saves power, and it doesn't tie up as many frequencies, right? You can get twice as many channels in now if you use 12.5 kilohertz. And this is what the Marine band has done. They've switched from the wideband FM to the 12.5 kilohertz. Sensitivity is the term that describes the ability of a receiver to detect presence of a signal. So here's the different filters that you can get. You can have a high, low-cut filter, which is background noise. You can tune in the station that you want, and this is called effective passband. You can do attenuation plus high-low cut. You shift the IF center, off a center with your BFO, or you can have RF gain plus IF shift, a high-low cut. So those are different methods of singling out that one station using some of your standard controls on your HF. A mixer is used to convert a radio signal from one frequency to another. So if we're receiving one frequency and we mix it with another frequency, if we subtract the two, we get the IF, which is the intermediate frequency. This is a block diagram of an AM broadcast receiver mixer. So signal A is at 800 kilohertz. Signal B is at 1255 kilohertz. You mix them together and you get, if you subtract those two, you get 455 kilohertz out. The term that describes the ability of a receiver to discriminate between multiple signals is called selectivity. The function of an automatic gain control AGC is to keep the received audio relatively constant, so it doesn't fade in and out. It prevents fading in and fading out. The RF preamplifier is installed between the antenna and the receiver. So here's a block diagram of a receiver. You have the antenna, the RF preamplifier, and that goes into the mixer. A transverter takes the output of a low-powered 28 MHz single sideband exciter to produce 222 MHz output signal. So you can use your 10 meter single sideband and produce a 1 1/4 meter output, and that's called a transverter, and it works both ways for receive and transmit. A good reason to use a regulated power supply for communications equipment is that it prevents the voltage fluctuation from reaching sensitive circuits. So you always want to use a regulated power supply for your radios. Alright, and that's the end of section 13, and we're going to go on to the Q&A sections next.